Hello everyone, so this will be our final video on the introduction section 5.2 to series. So the first thing I wanted to define was a very famous series which is called the Harmonic series, and the reason why this series is so well known is because interestingly the sequence 1 over n converges to 0, right? When you make n go to infinity, 1 over n, when you divide by 1 divided by a huge number, is going to go to 0. But the series, right, this sum here, actually diverges to infinity. So when you look at the sequence of partial sums, you'll see that the sum is always increasing, and it keeps increasing and increasing until it goes off to infinity. The series is interesting because it diverges to infinity very, very slowly, even though the sequence 1 over n converges to 0. Right, so I did a couple of the sums up here before the video just to show you guys, like, right, the first partial sum is just 1, the second one is 1.5, the third one is 1.83, 2.08, 2.28, 2.45. So as we see, we keep on getting bigger and bigger partial sums, and this is going to eventually go off to infinity. And then another series that's worth defining, right? We saw geometric sequences, and now we'll define what it means to be a geometric series, which is the same exact analogous concept where a geometric series is a series of the form the sum from 1 to infinity of a times r to the n minus 1. Right, so the first few times are a to the r0 plus a to the r1 plus a to the r2 plus so on and so forth. So that simplifies to, right, anything to 0 power is just 1, and 1 to the first power is just itself, right? So this looks like this, and it goes on forever, multiplying by r each time. So remember, r is what we defined as our ratio in a geometric sequence. So it's the same thing here, where to get from one term to the next, all you do is multiply by your ratio r. Right, so the interesting thing about this is that if the absolute value of r is less than 1, right, so if the absolute value of r is some fraction or decimal, right, the series, right, less than 1, the series converges, and we have a formula for its sum, and we know its sum. So we get that the sum from 1 to infinity of a r to the n minus 1 is whatever a is divided by 1 minus r, and that is for geometric series whose ratio is less than, absolute value of their ratio is less than 1. And then again, if the absolute value of the ratio is greater than 1, then the series diverges. So let's do an example of this. So this says determine whether each of the following converge or diverge, and I'm gonna choose one to do. So the one we're gonna do is going to be the sum from 0 to infinity of 2/3 n plus 2. Right, so if we write this out, we get 2/3. 0 plus 2 is 2, plus 2/3. 1 plus 2 is 3, 2/3, and then 2 plus 2 is 4, and so on and so forth. So if we try to simplify this, this becomes 2/3 times 2/3, that's 4/9, plus then we have 4/9, and then we multiply by 1 more third, plus now we multiply by 2 more thirds than the first one. So this is, right, this is our form. So now we know that, remember, the form of a geometric series, you have some constant a that's in each term, and then you have an r that gets multiplied each time. So that's what we try to figure out. And so when we look at this example here, we can see that we have the 4/9 on front each time. That's going to be our a, and then what's being multiplied each time is the 1/3. So that's our r then. Right, the thing we multiply by each time is our r. So a is 4/9 and r is 1/3. Oops, sorry, I'm writing 1/3 and it's literally right there that it's 2/3. I don't know where I got that from, so sorry guys, that's 2/3. Right, because remember in this one we only have 2 2/3, and then here we have 3 2/3, so there's 1 extra 2/3. Here we have 4 2/3, so there's 2 extra 2/3, right, and so on and so forth. So we see that since r, the absolute value of r, is equals to 2/3, which is less than 1, we know that the geometric series converges. Right, and then we have, remember now we have this formula here for geometric series converging. We know the sum, so the sum is excusez-moi, I'm so sorry guys. So this is going to be a over 1 minus r, which our a is 4/9 and our r is 2/3. So that's going to be 4/9 all over 1/3. So that's 4/9 times 3 over 1, right? We never divide by fractions, we multiply by the reciprocal, so that now we multiply across. 4 times 3 is 12 over 9, right? And we can divide both of those by 3, so that simplifies to 4/3. And one thing that I want to note is that you might find weird is that, why did this series start at 0? Well, it's the same thing. It doesn't matter where you start your series, right? So notice, right, that this series here, right, if we wanted to start it at n equals 1, we just need to make sure that our term is the same, right? So our first term is the same, right? So here our first term, the exponent is 2, right? Because it's 0 plus 2, so that's 2/3 2. I'm gonna just write the dot dot dot, since technically this is this whole sum, not just the first term. Right, so if I want to start it at 1, I just need to also make sure that my series still, if I want to start this instead at 1, I need to make sure my first term is still this term. So now I know that I only want to add 1 to it, right? And that will give me 2/3 1 plus 1, right, for my first term. And then that's going to be 2/3 squared. And then also, if you want to see it in